Yeah, so there's a lot of weird things going on, like Elon Musk is did he already send up a car into space? He was talking about doing that. A total waste, but what it does is it makes everybody think, gee, isn't this great? We're sending cars into space, there's no problems. You know,
Is
but
that an electric car or?
unknown. I believe it was a Tesla. I mean, he's got money, he can do anything he wants to, and he can waste it, which is one of the problems with there being so many rich and the rest of us poor, is that all that money represents wasted resources, so when these rich guys do that. But anyway, I'm going to talk about facts, which are these sorts of things, cell phones, radio. And you've seen this before, maybe, equations. This is gravity. This is electromagnetism that governs radio waves and stuff like that. Internal combustion engines, and the Navier-Stokes equations. Everyone may not know this, but I always say it. In 2003, there was the Acri versus New World Communication decision, which set a legal precedent saying it's legal for the U.S. News to not tell the truth, to lie, basically. So that's a legal precedent. Yeah, it's weird, isn't it? But Canada has the Radio Protection Act. They say the news must tell the truth. So as a result, the U.S. News can't broadcast legally in Canada. So that's just telling you how weird our world is. I mean, we all laugh, haha, the news doesn't tell the truth, but it's legally not required to.
Well,
So
it goes further back than that. In 1986, Ronald Reagan rescinded the Fairness Doctrine, which meant that news stations did not have to tell the truth. And 1 year later, Fox News was in business.
Right, but this is legal now. This is
Okay.
law. So demonstrations, this is always the fun part. Gravity is easy to demonstrate. And when I say facts, like I've had people come up to me and say, oh, that's a scientific theory, it's not a fact. Well, no, wait a minute. There are things we absolutely know. Now, if I let go of this piece of steel, we absolutely know what's going to happen to that. There's nothing you can do to stop that. That can't be stopped. So I show that thing to people. Another demonstration I do is electromagnetism, which is that guy. Interestingly enough, that's called a partial differential equation. This part here said, that part there just says the curl of the electric field. What that means is the electric field will curl around something, like a tornado. This other part here means how fast the magnetic field changes, which is fairly straightforward. So I put a bunch of wires around here. There's no batteries or anything. So now if an electric field curls parallel to these wires, it's going to make a current that will light the little light bulb. But how would I put a current into there? Well, I'd have to put a curling electric field. But I can do that by just putting a magnet in there quickly. Because how quickly the magnetism changes tells me how big the curl is. That's what an equation means. So again, just demonstrating facts. I've got a horseshoe magnet here. A pretty strong one. Yeah. So if I put this into that horseshoe magnet, all of a sudden there will be a sudden increase in the magnetic field. And that means there will be a curl in the electric field in these wires. And you should see the light bulb light up, which indeed you do, as you go in and out. So there's no way you could do this without that working. So this is, again, just a fact. And these are the kind of things I bring up to folks who want to discuss things like climate change and so forth. This is a new one I wanted to try.
A little more light, Patty?
Yeah, a little bit. Thank you. Maybe you could just flick on the lights, it'd be easier than that. So this is a really strong magnet. And as you might expect, a magnet doesn't do anything to wood, right? slides down like a piece of metal. This is just a piece of metal, no magnetism here at all. Well, it'll get attracted to that, but these aren't magnetic. So, and also the metal, and this is just aluminum, so it's non-magnetic. But this conducts electricity, unlike the piece of wood. So if I slide this down the piece of wood, it doesn't do anything because it's not conductive. Whereas this conducts, so when this moves, it's going to make a curl electric field. How do you like that? And in fact, it's not magnetic, you can see. But what it's doing is, as it moves, it's creating a curling electric field. And that curling electric field then creates a magnetic field, but in the opposite direction. So it pushes against this one's magnetic field. That's how magnetic brakes work.
So a magnetic field in that circumstance won't continue to build up per the length that it's going down the aluminum?
It tapers off as it goes in. That's called a skin effect. That's a good observation, though. And the faster it goes, the stronger. So if you move slowly, you don't feel much. But the faster you go, it can actually move the thing around. But here's a fun little demonstration. I have two different magnets. They're pretty strong, so there's a spacer. One magnet is stronger than the other. Can you tell which one is stronger?
Well, I'm guessing it's the one that's in your head.
That's right. Because it makes a stronger current, circulating current, that then pushes back harder on this one.
Yeah.
So these are just scientific facts. There's no mystery or magic here. But things like that are what govern climate change. That's why we know climate change is happening.
Due to magnetism?
No, not due to magnetism, but see all these equations? Magnetism is one of them, which is that. And I demonstrated gravity. You can demonstrate this for yourself by stepping off the roof if you don't. But this is the Arrhenius equation. These are the Navier-Stokes equations. This one's kind of fun to show. This is my rocket engine. And this brown layer here is unburned fuel that's used to cool the inside of the combustion chamber. And it ignites and makes the plume fatter. But if you turn off the oxygen, this is just kerosene burning out. And this stuff up here, black sooty smoke, is all what's called PM 2.5. This is actually illegal to release in the United States because what happens is there's not enough oxygen to make this burn clean. You know, and so what happens is the kerosene reacts with itself and builds larger and larger molecules until it eventually gets up to soot size, and these are soot particles. But they're all coated with carcinogens because this stuff here is carcinogenic. So that's why PM 2.5 diesel soot is illegal.